Okay, so we are going over special right. It's called special rights, but we're going to be going over special right triangles. Let me go over to here. So, um, one of the things that I was just telling you all was if there was a lesson that you would pay attention to for the next couple of chapters to really like lay a foundation of understanding what we're about to learn. I say the word trigonometry and people are like, ooh, it's not actually that bad. Trigonometry just means means three. So all you're going to be learning about is triangles. That's really what trigonometry is all about. It's triangles. Special rights. So we're going to be learning about these two very famous right triangles. If you learned them last year, like pull that out of your brain. If you don't remember, not a big deal. I will say if you listen to how I teach this, um, everything will make sense. Um, so I teach this in such a way, and I've been teaching this for years, that most of my students have no problem with this, including going into the next year of learning. So, all right. So today we're going to be able to find missing sides of special right triangles without using trig. Okay. So trigonometry just means the study of triangles. And when we say trig here, they're referring to sine, cosine, and tangent. And that is something that you learned last year. If you don't remember, I'll be going over it really quickly so that you can understand what's happening. It says, why are 30, 60, 90 and 45, 45, 90 triangles considered to be so special? And why can we find the missing sides of these right triangles without using trig? Are there any other special right triangles? Okay, so here we go. So I'm going to read off here because it's just easier. Okay, so the Pythagorean theorem and right triangle trig are both useful mathematical tools when we're trying to find missing sides of a right triangle. What do you need to know about a right triangle in order to use the Pythagorean theorem? So first of all, do you remember the Pythagorean theorem? Do you remember the Pythagorean theorem? It's kind of funny because I just used it today in my senior class as well. Okay, so do you remember the Pythagorean theorem? Yeah. Someone says a squared plus b squared equals c squared. Good. Very good. That is the theorem. Where's my little, there it is. Um, do you remember the requirements in order for you to use this formula? Do you remember what you have? Oops, I don't know. I did that. Do you remember what has to be true? What has to be true in order to use this thing? Yeah. All you have to remember is that it's a right triangle, number one. And number two, since it is a right triangle, you have to know who goes where. So I don't tend to write it like this. You'll see me write it like this. Let me see. Oh, nothing is happening. Please hold. Yeah. It's super slow today. It was super slow yesterday too. Let's see. There it goes. So I tend to write it like this. I tend to write it like um, leg squared plus leg squared equals hypotenuse squared. And then this will remind you of what a right triangle is. So a right triangle, really quick, has legs. It has two legs. And that longest side is called the hypotenuse. Oh man, you are like super slow. Here we go. There it goes. Okay, so the longest side is the hypotenuse. It's the side opposite. You'll hear me say this word over and over again. It's the side opposite of the hypotenuse. Now, this is something that I make my students do. So everyone do this right now. Okay. So number one, I'm going to pretend that your arms are two legs of a triangle. Oh, actually, it doesn't have to be a right triangle. So are two sides of a triangle. Everybody good? So here's my arms. You guys can see me. Sorry, internet, you can't. So here's my arms. Everybody open up your arms. Now so what do you notice about the angle between my arms? What happens when I make it smaller? What happens when my arms get closer versus when my arms get really, really wide? What is the relationship between those two? So what I'm doing, so that you guys can all see this. Let's see. So I'm drawing something. Oh, I could do it. Huh, I figured out a way to do this. I'm pretty slick, guys. Okay, so I have one of my arms is like this, right? And then I grab my other arm, right? And I'm going like this with my arms. I'm going like this, and I'm going like this. It's like I'm making this and this. So I want to see, what relationship do you see between the angle between my arms? You guys all see that angle between my arms? This is the angle I refer to. Okay. Okay. What is the relationship? What happens when I make the angle really big? Yes, the degrees are changing. What is happening to this side right here? If I drew a side length here, if I had a piece of string between my two fingers and I was making it smaller and larger. Yeah, so it grows and shrinks together. So this relationship is called a direct relationship, right? The bigger my angle between my arms are, the longer the opposite side is. Okay? I know that seems very, very obvious, but that observation alone will help you know who is the hypotenuse. And later on, when I draw my 30, 60, 90, it will tell you which side goes where. So please don't take this obvious thing, this obvious observation, lightly. Okay, so I'm going to refer back to my arms in a little bit, okay? Okay, so someone else said it has to be a right triangle. Absolutely. Most of my students, when I show them this a squared plus b squared equals c squared business, they always put whatever side is missing as your c. And that's not true, right? So whatever side is missing needs to go in whatever position it's at, if that's a leg or the hypotenuse, okay? So that's one of the biggest mistakes students will make. No problem. You guys have been using the Pythagorean theorem since probably 8th grade-ish. So you should be really comfortable with this. There's two ways that your brain should always go to whenever you see a right triangle. These are your two ways: Pythagorean theorem and trig. Pythagorean theorem and trig. So the moment that your brain sees a right triangle, you should be like, boom, I know what I'm doing. It's trig. I'm probably going to use Pythagorean theorem or trig. There's other things that you could be using, but these are the most popular tools whenever I see a right triangle. Okay, so what I want you to think about is when we're doing geometry or trig, I want you to think about all the tools that are in your tool belt. This is not like algebra. You don't start with a problem and then you follow these like prescriptive steps to get to your answer. This is geometry. I show you something and I'm like, okay, now prove it. Okay. So while using the Pythagorean theorem is fairly straightforward, you only have to keep track of the legs and hypotenuse of the triangle. The right triangle trig generally requires a calculator to look up values of different trig ratios. There are some right triangles, however, for which knowing a side length and an angle is enough to calculate the value of the other sides without using trig. These are known as special right triangles because their side lengths can be found relating them to another geometric figure which we know something about its sides. So I skipped this. What do you need to know about right triangles in order to use right triangle trig? Again, you need to know that it's a right triangle. Okay, that's the biggest thing you need to know. So in order for us to find the other stuff, it depends on what they give you, and then I will either use the Pythagorean theorem or I will use right triangle trig. My goal today is to have you decide very clearly, this is a Pythagorean theorem problem, Ms. Johnson, because I have blah, 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 and that means that I need blah, blah, blah. Okay. So one type of special right triangle is the 45, 45, 90. Okay. Draw a 45, 45, 90 triangle and assign a specific value to one of its sides. For example, let one of the legs measure 8 centimeters, or choose to let the hypotenuse measure 5 inches. You will want to try both approaches to perfect your strategy. Now that you are assigned a measurement to one of those sides of your triangle, find a way to calculate the measures of the other two sides. As part of your strategy, you may want to relate this triangle to another geometric figure that might be easier to think about. So the very first thing that I want you to do is I want you to draw a 45, 45, 90 triangle. Okay. In case you don't know what the 45 and the 45 actually mean, That's the angle measurements for your triangle. So first of all, draw that. So I do want everyone drawing that. It doesn't have to look perfect. Look, here's my drawing. There, that's pretty good. So because it's a 45, 45, 90 triangle, I'm going to write in here that this is a 45, 45, 90 triangle. So your goal right now is to figure out if, I don't know, they said if this is 8 centimeters here. Let's start with that one. If this is 8 centimeters here, I want to find the rest of these sides. Okay, I want to find the rest of these sides. So I'm going to pause the video so that you guys can think about this, and then we'll check back in a second. So I looked at one of yours, and one of you had 8 centimeters here and 8 centimeters here. So someone put 8 centimeters here. Why would someone do that? Is that correct? Do you agree with them? Someone said yes. But why is that true? Why is that true? Someone said it's congruent. Someone said it's equal. But how do you know that? In geometry, you can't just say something because it looks like it. Okay, you can't say that. Yeah, someone said it because the angles are the same. So this person is remembering a theorem that you might have learned. And it goes a little something like this. In a triangle, if two angles are congruent, then the sides opposite those angles are congruent. I'm going to say it again. In a triangle, since this angle is congruent to this angle, and I know these two angles are congruent because angles whose measures are the same, they're congruent, right? Angles whose, in a triangle, if two angles of the same triangle are congruent, then the sides opposite of those angles are congruent. Boom, boom. Yes. So the answer is yes. So this is actually a really neat way that you figured out that this was 8. All right, fine. But how would you figure out this third side? What would you do to figure out this third side? What would you do to figure out this third side? It is not 8 times 8. I'm going to give you a hint. Yeah, use the Pythagorean theorem, right? So go back up here. Whenever you're looking for stuff in a right triangle, your job is to look at 2 places. I'm going to keep saying this over and over again. The 2 places you should be looking are, number 1, what? Say it. You don't have to type it. Just say it out loud so that I know that you said it. You don't have to unmute yourself or nothing. Just say it out loud. So I have no idea. Yeah, so I think someone said Pythagorean theorem and trig. Since I haven't really gone over trig, we're probably going to use the Pythagorean theorem here. Ms. Johnson, how do you know you're going to use the Pythagorean theorem here? Number 1, it's a right triangle. Number 2, I know 2 sides. I need the third side. This would be a perfect match for my leg squared plus leg squared equals hip squared. Let me copy and paste because I'm just cool like that. All right, so you should be using this this formula right here to figure out what the hypotenuse is. I'm going to give you a couple seconds to do that. Go ahead and work. So I think you guys figured this out. So I'm going to plug this in. Each of these are legs, and I'm going to be looking for my hypotenuse. So I'm going to make this as my h squared. So that's 8 squared plus 8 squared equals h squared. So that's 64 plus 64, that's 128. So that's 128 equals to h squared. And then I'm going to take the square root, and then I'm going to say some funny things, and you guys should be remembering everything. So when I take the square root, don't forget to take the what. Don't forget what. So I think I've said this to my other class a bunch of times, maybe not to your class. I'm going to say this. Whenever you take the square root, you also have to include plus or minus. So my answer for this equation is h is equal to plus or minus 64 2. So this would be 8 root 2. Do I need to review how to simplify this? Do I need to review how to simplify this? Are you guys good? I've got no nods in the crowd. Yes? Review. Okay. Square root of 128 looks like this. Uh-oh. Ooh, my face exploded. Okay. Square root of 128. All I do is I figure out the factors of it, and I'm looking for pairs. because I just did 8 squared plus 8 squared, I know that this is 2 times 8. Times 8. Sorry. 2 times 8 times 8, right? And so do you see how I have a pair right here? So because I recognize that this is a pair, pairs of shoes get to be played on the outside. Loaner shoes, like literally pretend that you're at the store and you find one shoe. And you go up to your mom and dad and you're like, hey, can I buy this one shoe? And your mom's like, what? Why would you want one shoe? So those single shoes have to stay inside the store until they find their match, right? So same thing with the shoes. Pairs of shoes get to be written on the outside. So this 8 on the outside represents 2 8s on the inside. It's really, because another way for you guys to think about this is equal to the square root of 2 times the square root of 64. And then you all know that the square root of 64 is 8. So this is 8 times the square root of 2. Good. All right, so I solved this equation. My answer is plus or minus 8 root 2. But because we're talking about the side length of a triangle, in this case the hypotenuse, I throw out the negative because we don't deal in negatives. We don't deal in negatives. So my answer is 8 root 2. Anybody, so the moment that something happens like this, the first thing that you should do is like, I wonder if that's a coincidence. I wonder if that's a coincidence. And then in your mind, if you're wondering if that's a coincidence, your mind should jump to another number, like say the number, I don't know, 5. And then so you go, oh, that would be like 5 squared plus 5 squared equals h squared. So that's 25 plus 25. So that's 50. The square root of then it's going to be like root 2 times root 25. Oh, it's going to be 5 root 2. Ooh, look at my pattern. Does anybody see the pattern? Do you see the pattern? Do you see the pattern? What pattern do you see? So if I put a 12 here, would you have to use the Pythagorean theorem to figure out what goes here? That's the pattern I'm asking you about. Okay. So you're thinking, I'm reading, generalize your strategy by letting one side of the triangle measure x. Show how the measure of the other two sides can be represented in terms of x. Make sure to consider cases where x is the length of the leg, as well as the case where x is the length of the hypotenuse. We didn't consider the length of the hypotenuse just because you will get enough practice of that later. So I'm going to show you what they're asking you to do. So they're asking you, hey, if I have a generic 45, 45, 90 triangle. So whenever I do my 45, 45, 90 triangle, this is what I draw. I draw the angle. I draw as much as possible so that it looks like half of a square. By the way, when they said, if you can relate it to another geometric figure, another way to do this is to pretend that you were in a square, right? So if I draw the rest of that square in, you would have known if this side is 8, then this side has to be 8. And you know that when you draw the diagonal of a square, it splits that angle into 2. We call it bisect. It bisects that angle, right? So whenever you hear bisect, your brain should say 2 congruent parts. 45 degrees on this side, 45 degrees on this side. Meaning that this and this were both 8 and 8, right? So, but now we're going to go into to generalize it. If this side is x, what else do you know? If this side is x, what else do you know? Very good. Someone's like, hey, Miss Johnson, the congruent angle is also going to be 45 degrees, and that makes this side x because of what one of your classmates helped us remember. Or maybe you like the square idea and you're like, but Miss Johnson, this is half of a square. If this is x, then this has to be x. Whatever you wanted, you just told me that you know this is x. So this is almost done. Almost. So the only side I'm missing is this guy. How long is the hypotenuse? Now we can jump over here to the Pythagorean theorem. In fact, I will. We'll go x squared plus x squared equals to h squared, right? I'm solving for hypotenuse, right? Yeah, actually, that's the correct answer. So some of you already saw the pattern. You already know what goes here, but I'm going to continue. So this would be 2x squared equals to h squared, right? And then I would square root both sides, right? And so I would get h is equal to plus or minus. Now do this with me. What's the square root of 2x squared? What is the square root of 2x squared? What's the square root of 2x squared? So look up here, right? What would it be equal to? Yeah. So the x squared gets to come out because I have two x's. So that's x. That root 2 doesn't get to go outside because he doesn't have a pair. So he's left inside. So my answer is plus or minus x root 2. Again, because we're dealing with triangles, we're only going to take that positive guy. So Miss Johnson, there was a pattern. So the more your brain says, huh, I wonder if that's a pattern. Can you walk down that road and check to see if it's a pattern, right? Walk down the road of, whenever I see Miss Johnson on a Tuesday, she wears that one t-shirt. I don't know. I'm just making stuff up, right? And then you would check your pattern. You would check, maybe you have a post-it and you're like marking off every single Tuesday that she wears the same t-shirt. I don't think I wear the same t-shirt on Tuesday. Hopefully one of you would tell me if I was. It's showing up pretty slow here. It does say x root 2, so I'm just gonna wait for that to show up. So this guy right here, you're gonna see me draw him over and over and over and over and over again. So if this can go from the screen into your, onto your paper, back into your head, that's where I want it. I want this picture there. So the next one that we're going to learn, not right now, is we're going to learn about the 30, 60, 90 triangle. We're going to learn about this 30, 60, 90. So we just started this thing. Feel comfortable with this guy. If you're uncomfortable, just every now and then just draw him and then write x, x, x root 2. Again, just make sure that you're comfortable with this guy. So now that I know this, I'm a little bit more comfortable with this right triangle trig here. Okay. All right.